6-5. We're going to do all of 6-5. That sounds like a lot. It's really not that bad. Now here's the thing. Every chapter, we usually learn something new, and then we solve equations involving it, right? So we're going to solve two types of equations. We're going to solve radical and rational exponent equations. Okay. Rational exponent equations. Now, with solving, as you know, you might know, you need to show work, okay? Now, here's what I mean. You don't need to write this down, but if I gave you something like this, okay? 2x plus 1 equals 7. Now, I know you're in Algebra 2 now. You're really good at math. You're doing great. You can probably solve that in your head. That's great, and I don't mind that, okay? Now, what I mean by work is if it's harder than this and you're going to show some work, you would need to subtract 1. This is the work that I want to see. Divide by 2, x equals 3. So let me go ahead and show you a couple of things that I like to see when you do work. Number 1, you need to write the problem down, okay? So only time I make you write the problems out of your book onto a piece of paper. You have to write the problem down. Then you get to show the meaty part, the work. Number 2, show work. Sometimes I collect homework, and some of you guys know this. I'll look at it and I'll hand it right back. Have you ever seen me do that?
Not yet.
No, not yet. You might. And I'm like, nope, I'm not even going to accept this because it doesn't have any work on it. Just answers. There's no way. And then finally, the third thing is I like you to box your answer. Put a box around your answer so that it's easy for you to grade it when you come back on Tuesday. Okay? So write the problem down, show the work, put a box around your answer. And when you show work, it's really important to go down the page. Okay? It's a column form of work. Some people like to write it next to each other. It doesn't make any sense. That's how you do real math. Okay, so here we go. Part A. We're going to start with some radical equations. These are not hard. You're going to like these. The hardest part is just going to be the last problem we do. There's a little tricky part to it, but otherwise today's going to be nice, breezy, easy. All right, so here's what you want to do. There's 2 steps to solving radical equations. Number 1, you want to isolate the radical. So if you have a radical and there's some stuff around the outside of it, you want to bring that all over to the other side to get the radical all by itself, okay? Isolate means to, get it by itself. Isolate. Number 2, then you are going to square both sides. So if I'm solving for something that has a radical of x, to get rid of the radical, I square it. Square both sides. All right, pretty basic? Okay, I'm going to do 2, and I'll let you do the third one. Let's do it. Number 1. Here you go. Write this down. We're going to show work going down our page. We have 2 plus the square root of 3x minus 2 is equal to 6. Okay. So write that down. And then we're going to show work on how to solve this. We're solving for x. We want to find out what x is going to be to make this whole thing equal to 6. So our first step is to subtract 2. Very good. We're going to isolate the radical, get that thing all by itself. Now, we are not allowed to, add this 2 and divide by 3. That's all underneath the radical. The radical is completely isolated now. So square it. Exactly. We're going to square both sides, because remember the golden rule of algebra? Do unto one side of the equation that you do unto the other. Golden rule of algebra. What did she say? Oh, I've never heard that, but I love it. Okay. It makes sense, though. So then you get 3x minus 2 is 16. Now, from here, okay, I'm not going to be so picky. If you can do the rest in your head, good. I hope you can, really. I really do. Okay? If you can do that in your head, great. If not, add the 2. 3x equals 18. Divide by 3. X equals 6. Put a little box around it, and there you go. Now, if I'm taking a quiz or I'm taking a test, I would probably be so extra as to check my answer. That's just me. Are you extra? No? Some of you are. You just won't admit it. So, by being extra, I would plug 6 in, and I get 18 minus 2. So I get 2 plus the square root of 16 equals 6. Perfect. I checked my answer. You don't have to. It's just homework. But if you did want to check to see if you got it right, you could. All right, let's do number 2. Here we go. Let's say we have 2 times the square root of 5x plus 1 minus 12 equals 0. All right, I added one extra step to this one. So you have to isolate the radical. What that means is this radical right here needs to be all by itself. Kind of like me when I get home from school. I try to isolate myself. My kids, they just want stuff, whatever. All right, so we're going to add 12 to both sides. And we get 2 rad 5x plus 1 equals 12. Okay, I'm showing all the steps. I mean, I know that you can skip a few steps, and I'm okay. And so then divide both sides by 2 so that we isolate the radical. So just the radical by itself. It still had a 2 out here, so we had to get rid of that. So I get rad 5x plus 1 equals 6. All right, so that's just the first step, is to get it by itself. And now we we square both sides. Square and square. I don't have a square to spare. 5x plus 1 equals 36. And then the rest, if you can do it in your head, good for you. If you can't, that's okay too. For me, I'm a pencil and paper kind of a math student. So I get 5x equals 35, so x equals 7. Yay! See, I knew you'd like these. Well, maybe like is too strong of a word. All right, you get to try one. Here we go. You try this one. Negative 10 plus rad 2x plus 1 equals negative 5. All right, I'm going to let you try this one all by yourself, quietly. Okay, so we think it's 12. So first thing you did was you added 10 to the other side. By the way, I haven't told you this, but this only works when the radical is equal to a positive number. You see, if the radical was equal to a negative number, we wouldn't be able to do it. Do you remember those earlier in the year we did absolute value equals a negative number and we got some of you? Mm-hmm.
Yeah, you got me.
Uh-huh, see? The answer was no solution. But then you did the equals that and that. Yeah. Okay, anyways, it's a positive number, so let's square both sides. 2x plus 1 is 25. Subtract 1, divide by 2. X equals 12. Who got that? Yes, like all of them. Wow, I'm the best teacher ever. Okay. See? Even my mug says it. It's crazy. All right, part B, second part. Here we go. Now we're going to do some rational exponents, or fractions, fractional exponents. Rational exponents, and we're going to do things like this. Now, it's going to look kind of difficult at first. Like, you know, if you had a radical, the square root of x equals 5, it's pretty easy to figure out what x is, even just by looking at it. The square root of what gives me 5? 25, right? Yeah. If you square both sides, you get x is 25. Okay, but a rational exponent is a little bit tougher. Like, if you had, is there squabbles? Are we okay? If you have x to the 3/2 is 8. That's hard to do. You can't figure that out just by looking at it, probably. I mean, I don't want to say you can't, but maybe you can't. Okay, so what number to the 3/2 gives me 8? I don't know. It's not 6. Did you say 6? It is a number that's 1 through 10. Very good. Okay, here's how we're going to do this. This problem has 2 parts, right? This x is being cubed, and it's being square rooted. That's what 3/2 is. Okay, so we can do this one of 2 ways. We can do it in 2 steps, which I don't like to do, or just do it all in 1 step. One step. Here's what you do. Do you see how it's raised to the 3/2? Let's go ahead and do the reciprocal of that. Let's raise both sides to the 2/3. And you're like, why would we want to do that, right? Like, that's scary. Well, when you multiply that together, what's 3/2 times 2/3? It's 1. The 2's reduce, the 3's reduce, and what am I left with? X. And x equals 8 to the 2/3. Well, that you know how to do. I mean, I hope you do. We just took a quiz on it. This is what? The cube root of 8 squared. How many of you guys do those on your calculator? That's okay. I won't math shame you. That's fine. Yes, if you do that on your calculator, 8 to the 2/3, you will get, and Andrew got this 4 hours ago, x equals 4.
Oh.
He did. He's all 4. X equals 4. 4 to the 3/2 equals 8. It does. Okay? So that's going to be the key on this problem, on these problems. So our first step is going to be to isolate the power part. I don't know what it's called. Isolate the power. That sounds like a strong thing right there. We're out on a strike and we're isolating the power. All right. Isolate the power, and then step 2 would be then to raise both sides to the reciprocal power. Ooh, that's a fancy word. Reciprocal power. Okay? You guys know what reciprocal is? Good. Okay, just flip the fraction. All right, you ready to do some of these?
Yeah,
sure you are. Thank you, that's nice. Number 4. I've got 3 of these. 2 are going to be regular, the last one's a little tricky. Here we go. We've got 2 times x plus 2 to the 3/2 equals 54. Whew, all right. We stepped up our game a little bit here, didn't we? It's a little bit more difficult than the last one looked like, but we're going to do it the same way, okay? So our first step is to divide by 2. We've got to isolate this power part. So divide both sides by 2, and we get x plus 2. Yikes, that was ugly. X plus 2, to the 3/2 equals 27. Very good. Okay, so we did the first step, isolate the power part. Now do not subtract 2 out of there. You're not allowed to. It's still being held captive by this 3/2. And so what we're going to do now is take both sides to the what? 2/3. Yes, both sides to the 2/3. Okay, what that does over here is it gets rid of that radical, or not radical, but that exponent, and you get x plus 2 equals. Now, if you need to use your calculator, I guess it's okay. Ooh, we were doing some fun graphs earlier. That was fun. All right, so we got 27 to the 2/3. Now, if you can do that in your head, I think it takes longer to put this into my calculator than it would to do that in my head. You get 9.
That's good for you.
No, it's good for all of us.
It's not good. I can't.
You can't do that in your head? Yeah, you can. Take the cube root of 27. 3. Square that number. 9. Okay? Cube root of 27 squared. All right, and then finally subtract 2, so the answer is 7. All right, you try one of these. You try one of these. You can do it. You try this one. 3 times x minus 1 to the 3/5 equals 24. All right, you try this one quietly. I'm going to divide by 3. You should have gotten what? 33 was the answer?
31.
33.
Oh wait, no. I put +1, but I subtracted it.
Oh, whoopsies. All right, divide by 3 first. X minus 1 to the 3/5 equals 8. Raise both sides to the 5/3, the reciprocal. That's my favorite part. I really like that. And then we get x minus 1 equals 8 to the 5/3. Now, if you couldn't figure out what 8 to the 5/3 was, I saw some of you guys get your calculator out. And that's all right, 8 to the 5/3. Every time I say it's all right, I'm a little disappointed, huh? I don't mean to do that. It's just instinct. And then you add 1 to the other side, and you get 33. Yeah? It wouldn't? On your calculator?
Or it's just I was putting it
Oh, okay. You have to put parentheses around in yours.
Man.
Yeah. So, yeah, with the old calculators, they go like this, and then you have to do parentheses 5/3 to tell your calculator that you're raising it to the whole thing. If not, your calculator thinks that you're doing 8 to the 5th divided by 3. Big difference, huh?
How would you freehand 8 or like the thing with 5 and 8? Could you freehand that?
Yeah. The cube root of 8 to the 5th.
No. Oh,
Cube root of 8 is 2, and 2 to the 5th is 32.
I see what I did wrong now.
Oh, okay. All right, last one. We're here. We've made it. And it's got a little extra on it. Little weird. Okay. Yeah, a little something. I'll show you. 2 times x minus 2 to the 2/3 equals 50. Okay, so same idea. It doesn't look any different, you know. It's really kind of not until you get to the last part. So divide by 2, and you get x minus 2 to the 2/3 equals 25. And now we're going to do the same thing. we're going to raise both sides to the reciprocal. And the reciprocal of 2/3 is 3/2. Okay? And then you get x minus 2 equals. Now here's where we have to be careful. Because what I'm doing, and I haven't done this yet, but what I'm doing is I am taking, oh, that's not a pen. I'm taking the square root of both sides of an equation. And do you remember when you take the square root of both sides of an equation, you get how many answers?
2.
You get 2. 50 answers. You get 2 answers, plus or minus 5. And so that's what we need to do here. Because it's an equation that I'm solving. Now if I go to my calculator and I go 25 raised to the 3/2, it's only going to give me one answer. Well, if I do the square root of 25, that only gives me one answer also. But if I'm solving an equation, I know I have to do plus or minus. Okay? So when this number is even, this number right here is the square root. You wouldn't do it if it's a cube root or fifth root. You don't take plus or minus. When it's a square root, you need to do plus or minus whatever that answer is. Okay, that's the tricky part. Yeah, I know, it's not very fun. And then add 2. So we get 2 plus or minus 125, and don't leave it like that. We need to say what the 2 answers are. 2 plus 125 is 127, and 2 minus 125 is negative 123. Both, see, when I'm solving an equation, I need to find any answer that's going to work, and they both work in that equation. Okay, so that's the only time you need to be aware of that. That's very special right there. I'll put some stars and some fun around it. There you go. All right, that's